Hello viewers, good day to you all. You're welcome to today's class. I remain your pro guide, Aisha Bende, and this video is proudly sponsored by Proch Connect. Proch Connect is an application for undergraduate university students. Kindly go to your Play Store to download the application known as Proch Connect. So we are going to solve a question today which is from Federal University Lokoja in Kogi State from the Faculty of Sciences, which is under the Department of Mathematical Science. This is a question from 2022-2023 examination, and we shall be solving question number 5B today. So the question reads, solve the system x equivalent 1 modulo 2, x equivalent 2 modulo 3, x equivalent 3 modulo 5. So we are required to use a Chinese remainder theorem, which is known as the CRT. So before we begin, I would love to explain what we mean by the CRT, some of the applications in real life. The CRT is the result in number theory and algebra that provides a way to solve a system of simultaneous linear congruence with pairwise procrime moduli. Okay, so there are some applications of the CRT in real life. One, it is used in computing very large numbers in computer science and also in cryptography. Number two, it is used in error detection and correction. The third application is it is used in calendar system to determine the day of the week given a given date. Okay, and the fourth application is in telecommunication. It is used in signal processing. So these are some of the real life application of the Chinese remainder theorem. So let's solve the problem we have on the board. Looking at this question, we have three conjugates in this question. Okay, so let's start. These are the three linear conjugates we have from this question. So the first thing, there are some parameters. For us to begin solving this, there are some parameters we need to bring out from this system. So the parameter we need is we need the value for A1, A2, and A3. Okay, so A1, A2, and A3 are the values for the x, which is 1, 2, and 3. So A1 is 1, A2 is 2, while A3 is 3 as given from the question. The next thing we need to get is the values for N1, N2, and N3, where this N as small letter n, okay? So the values for the N are the modulus. So the first one now is in modulo 2, the next one is in modulo 3, while N3 is in modulo 5, okay? Then after getting the A1 to A3 and N1 to N3, the next thing for us to get is the value for capital N1, capital N2, and capital N3. So for us to get the capital N1, it's going to be the product of the small n2 and n3, okay, without the value for the n1. So that means n1 is going to be 3 times 5, which is equals to 15. N2 is going to be the other two values of the smaller n, which is n1 and n3. So n2 is going to be small n1, which is 2 times small n3, which is 5. 2 times 5, which gives us the value of 10. Moving on, for us to get n3, it's going to be equals to, that is the value of small n1 and n2, which is 2 times 3, and this is equals to 6. So now we have n1, capital N2, and capital N3. So from here, the next thing we are to get is what we call the value of capital N. This is going to be 2 times 3 times 5, okay? So we have 6 times 5, and this gives us the value of 30. So our capital N is equal to 30. Okay. From this point, the next value we need to get is the value for y1, y2, and y3. Okay, and the value for us to get the y1 to y3, we are going to use, which is y of I multiplied by capital N of I equivalent to 1 multiplied by modulo n, small n of I. So with this relation now, we can get the value of y1, y2, and y3. So for I equals to 1, this is going to be y1, n1 equivalent to 1 modulo small letter n 1. So this is how we get the value for y1. Okay, that is from this relation. Here we are going to have y1, our capital N1, which we have, so you multiply by 15. This is equivalent to 1 modulo. Value for small n1 is 2. So here we're going to have 2. So this is the same as saying 15 modulo in modulo 2 is going to be 1. This is from our secondary school arithmetic under modular arithmetic. So 15 modulo 2 is going to be 1 because 15 divided by 2 is 2 remainder 1. So the remainder there is our modulo. So here we are going to have that y is equivalent to 1. So let's move on to the next one. For I equals to, that's for 2 now, is going to be y2 n2 equivalent to 1 modulo n2. So let's substitute in. So now we're going to have y2 multiplied by n capital N2, which is 10, is equivalent to 1 modulo small n2, which is 3. So from here, for us to get the value of y2, we can see we have 10 modulo 3, and 10 modulo 3 is 1 because 10 divided by 3 is 3 remainder 1. That means y2 is equivalent to 1. Okay? So moving on to the last one, at I equals to 3, we use the relation y3 n3 is equivalent to 1 modulo n3. So here we have y3 multiplied by capital N3, which is 6, equivalent to 1 modulo and small n3, which is 5. Okay, so as you can see, here we have 6 modulo 5. That's going to give us what? 1. Because 6 divided by 5 is 1 remainder 1. So y3 is equals to 1. So from here we have our values for y1, y2, and y3. From here, the next step is for us to get the value of x, and x, we say x is equivalent to. Now the values we'll be needing to get our x is the value of a1 to a3, then our capital N, and the value of y1, y2, and y3. So with this, we can get our value for x. So this is going to be, now let's go with the first one. So it's going to be a1, n1, y1 plus a2, n2, y2 plus a3, n3, y3. So this is going to be in modulo capital N. Okay, so with this relation, we can get the value for x. So this is x is equivalent to, now let's substitute in our values. A1 here is 1 times our n1 is 15 times our y1, which is 1. Then plus open bracket, our a2 here is 2 times n2 is 10 times y2, which is 1, plus a3, which is 3, multiplied by n3, which is 6 times y3, 1. Okay, all of this in modulo n. Our modulo n now is 30. So here we are going to have 30. Okay, so let's simplify. Here we have x is equivalent to 1 times 15 times 1 gives us 15, plus 2 times 10 times 1 is 20, plus 3 times 6 times 1 is 18. So all of this in modulo 30. Okay, so when we take the sum of this, we have x equivalent to 15 plus 20 is 35. 35 plus 18 is 53. So here we have 53 modulo 30. Okay, so from here, let's get 53 modulo 30 is going to be what? So we have x is equivalent to 53 modulo 30, that is 53 divided by 30 is 1 remainder 23. So this is going to be what? 23 modulo 30. So this is our final answer. Our final answer is what? 23 modulo 30. So we've solved the system using the Chinese remainder theorem to get a value of 23 modulo 30. Hey students, there's something interesting about mathematics generally and calculations. When you've arrived at your final answer, you can always check if your answer is correct. And under this question, we can check if our answer is correct. from the final answer, here we have 23 modulo 30, right? So, so let's check from here. This is 23, right? Now let's come here. Hmm? This will let, from here we can check if our answer is correct. What is 23 modulo 2? 23 modulo 2 is what? Is 1. Because 23 divided by 2 is what? Is 11 remainder 1. So this is 1. So this shows that this is correct. Let's test for the next one. We have 23 modulo 3. 23 modulo 3 is what? 7 remainder 2. So that's this remainder here, 2. So this shows that we are correct. And to check again for the last one, 23 now modulo 5. 23 modulo 5 means 23 divided by 5, which is 4 remainder what? 3. So this is the 3. So from here, our final answer correlating with the questions shows that the answer is correct. So when you get to your final answer, my students, you can always check under the Chinese remainder theorem to know if you're correct or not. So thank you for watching. If you have any question, kindly drop your questions. If you have any further question you want us to solve on this app, kindly bring in your questions and we'll take it up from there. Thank you for watching. God bless you all. I remain your pro guide, Aisha Bandi. Bye for now.